Hey everyone, it's Bradley Bush again with another algebra video. Today we're talking about systems of linear equations in two variables. We are in two space because we have two variables, so you'll see a Cartesian coordinate system in the graphs that we draw. And the to-do list today, first we'll do a quick review. We'll talk about systems of equations in two variables so you know what that phrase means. And then we'll discuss a method that we use to solve these systems. And that method is the addition method. We'll have two examples of those. And by the way, I have all of the video elements listed out with their timestamps in the description of the video. So if you want to skip to a certain spot, that's perfect. Please do. Let's start. Well, what is actually a system of linear equations in two variables? Let's break it down really quickly. Two variables, that just means we literally have two variables. Usually they're x and y. These variables all have an exponent of 1 on them, so that means they're linear. That means these equations describe a line. So we will have generally two of these equations in each system. System just means we have more than one of them. So we generally have two. And these two equations in the system represent lines, and that's it. Really simple, right? So it sounds complicated, but it's not. Here's an example of a system of linear equations in two variables. You notice all the variables have 1 as an exponent, and because they have 1, it's implied. We don't write it. I label all of my equations with a number with a circle around it, so you know it's a label. So I have two equations, equation 1 and equation 2. Not bad at all. People ask, what does a solution look like for these systems? Well, because these are two lines, the solution is a point that is on both of the lines simultaneously. So the solution will be a point, an xy coordinate. There are three possible solution options when you're doing these problems. One solution, no solutions, or infinite solutions. So if you're in the one solution category, that means your two lines cross once, and that's it. Or they don't cross at all because the lines are parallel, or they cross everywhere, they touch everywhere because the two lines are actually the same line. They're right on top of each other. So those are the three options you have for solutions. Some people ask, how do I know which of the three options I'm in when I'm doing a problem? Well, you just start the problem. And if you get an answer, you're in option 1. That means you only have one solution, as long as you did your algebra correctly. Otherwise, as you're going along, the variables will drop out. They'll disappear. And you'll be left with numbers and an equal sign. If those numbers and equal sign make a true statement, like 2 equals 2, then you know you have the infinite solution case on your hands. And that is option 3. If those numbers make a false statement, like 0 equals 2, then you know that you have no solution, and you're in option number 2. How do I solve these types of systems? Well, there are two different methods that students use. One method is the substitution method, and one is the addition method. And this video discusses the addition method. I have another video that discusses the substitution method if you want to take a look at that in my algebra playlist on my channel. So the addition method, the main idea is that we want to eliminate one of the variables so that we can solve for the remaining variable. And we do that by adding the two equations together in a way that makes one of the variables disappear. Then once we have just one variable, we solve for it, and then we use that to plug it back into the original equations to get the variable we don't have. So pretty straightforward. Let's do an example. So I have two examples here, one on the left and one on the right. We'll do the one on the left first. So here's our system. Equation 1 and equation 2. If we try to get rid of the x's, it looks like we literally could just add the two equations as they are. Sometimes we kind of have to manipulate the equations before we can add them and something cancels. But here we just add them straight up because we have a 2x in equation 1 and a negative 2x in equation 2. So let's do that. And because we're actually not changing anything, I'm just going to copy and paste these. That didn't work. There we go. So when we add, the x's drop out. So we get 0 here. And we have -3y and positive y, which gives us -2y. And we have a 0 right there. We can then divide by -2 on both sides. And we get y equals 0 over -2, which is just 0. So that's nice. Now we can plug y equals 0 into one of the first equations we had, equation 1 or equation 2, and then we can solve for x because we already know what y is. So I choose equation 2. And equation 2 was -2x plus, and there's a y here, and then equals 4. But instead of having the y, we know what y is. Y is 0, so we'll plug it in. And now we just solve for x because that's all we have left. So we have -2x equals 4. And if we divide both sides by -2, then that gives us x equals -2. And we found our xy coordinates. So we found one solution. So our answer then would be x equals -2 and y equals 0. That's the solution to our system. And if we look at a graph, you can see here's equation 1, here's equation 2, equation 1, equation 2. They're the lines. They cross where? One point, and that point is -2, 0, just like we had in our answer. Not bad at all, right? Well, let's try this again with a different problem. On the right here, we have equation 1, equation 2. And if we want to get rid of a variable, let's try to get rid of the x's again. If we just multiply one of the equations by negative, then when we add them, the x's will fall out. So if we multiply equation 2 by -1 and then add it to equation 1, we should be good to go, right? So what is -1 times equation 2? That gives us -2x. -y equals -4. And let's label this one. This one is equation, we'll call it 2.1 because it's not equation 2, it's our newer edition of equation 2. And then 1 just stays the same, right? So we'll just copy it down. 2x minus 3y equals -4. And now when we add them, just like we wanted, the x's cancel out, and we have 0 minus 4y equals -8. And if we divide by -4 on both sides, what do we get? We get y equals +2. That's nice. Now we've found y, we can go back and solve for x. So we can plug in y equals 2 into either of our original two equations, equation 1 or equation 2. So I choose to plug into equation 2. Personal preference, there's no reason really, except for I think it's easier because if you look at equation 2, you see that y is by itself, so I don't have to multiply it by anything, but that's the only reason. So I'm going to plug y equals 2 into equation 2. Equation 2 we can see here is 2x plus, and there was a y, right, equals 4. But instead of having that y, we're going to put 2 in because we know what the answer for y is. And then we just solve for x. So we have 2x plus 2 equals 4. We need to get the x by itself, so we'll take 2 over. That gives us 2x equals +2, and now we need to divide by 2, and that gives us what? That gives us x equals 2 over 2, or 1. So our solution then is x equals 1 and y equals 2. And if we look at the graph, we see equation 1 and we see equation 2, and where do they cross? They cross once at the point 1, 2, which is what we found algebraically. Hopefully this helps. This is how you use the addition method to solve a system of linear equations in two variables. If it did help, subscribe to the channel, and thanks for watching. Have a great day.